Hello, good people. Hello, O-level candidates. This is TOC Mathematics video lessons. So we are introducing video lessons to help you to study wherever you are. We know that distance is not a barrier. You can study and you can learn even at home. So take advantage of these initiatives so that you will benefit as you prepare for your final examination. Right, today I want to talk about functional graphs. Then I will focus on number one, linear functions or linear graphs. Then secondly, I'll talk about quadratic functions. Quadratic functions. Okay. We must know that these functions, these graphs, are drawn on a Cartesian plane. When we are talking about a Cartesian plane, it involves two lines. Cartesian plane. Right, it involves two lines, a vertical line and a horizontal line. Okay, a vertical line is called y-axis, a horizontal line is called x-axis. So when you think of Cartesian plane, or when you want to draw a Cartesian plane, think of any number line. So this line is representing the values of y, and this horizontal line is representing the values of x. And where the line intersects, we call the region, we call the place origin, which is 0. Okay, so the top part of the y-axis represents the positive values of y. So when we are given a scale, for example, let's say 2 centimeters represents 1 unit on both axes. We say 1, 2, 3, 4. Then below x-axis, in terms of y-axis, we say -1, -2, -3, and -4. Then same applies to the x-axis. To my right, it represents the positive values of x. So from this origin, we say 1 and 2, 3, 4. Then to my left, it's now the negative side. -1, -2, -3, -4. So all the graphs of functions, we draw them on a Cartesian plane. So we represent the algebraic functions and all functional graphs on a Cartesian plane. Okay, I'm sure we are together. So for instance, if we are given a scale, e.g., if 2 centimeters represent 2 units, we say 2, 4, 6, etc., etc. And again here we say 2, 4, 6, 8. Then here -2, -3, sorry, -4, -6. Here -2, -4, -6. Okay, I'm sure you are with me. Okay. Now let us move on to linear functions. Linear functions, which are straight line graphs. Linear functions. Okay, there are simple linear functions. For instance, number one, if we are asked to draw a function y is equal to 2, right? Y is equal to 2 is a horizontal line which crosses the y-axis at 2. On our Cartesian plane, this is the origin, right? 1, 2, -1, -2, 1, 2, -1, -2. So we are saying the line y is equal to 2. This is the y-axis. This is the x-axis. So the line y is equal to 2 is a horizontal line which crosses or which intersects with the y-axis at 2. So this is the line y is equal to 2. Okay, number 2, if we are asked to draw the line y is equal to minus 1. Again, this is a horizontal line which crosses y-axis at minus 1. The horizontal line which intersects with the y-axis at minus 1. So this is the horizontal line. Please, when you draw, when you practice your questions, you must use a ruler. I'm using a freehand because this is the available resource which I have right now. So y is equal to minus 1. Again, let's say we're asked, number 3, example number 3, let's say we're asked to draw the line y is equal to 0. Right. Again, the line y is equal to 0 is a horizontal line which crosses the y-axis at 0. And if you do this, you realize that the x-axis, this line, the x-axis is the line y is equal to 0. Because this is the horizontal line which crosses the y-axis at what? At 0. So the x-axis is also called the line y is equal to 0. Okay, we now move on to lines which involves the axis, or which involves the letter x. For instance, number 1. If we are asked to draw the line x is equal to 4. Now, this is a vertical line which crosses the x-axis at 4. Or this is the vertical line which intersects with the x-axis at 4. So if we are asked to represent this graph, to draw this graph on a Cartesian plane, this is the origin, 1, 2, 3, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, minus 1, minus 2, minus 3, minus 4. So the line x is equal to 4. This is the line, a vertical line, which crosses, which intersects with the x-axis at 4. So number 2, if we are asked to draw the line x is equal to minus 2. Again, this is a vertical line which crosses, which intersects with the x-axis at minus 2, I mean. The vertical line, this is the vertical line, a straight line. The line x is equal to minus 2. This is x is equal to 4. Okay, I hope we are moving together. Now, number 3, just like what we did in terms of y, now let us do the line x is equal to 0. Again, this is a vertical line which intersects with the x-axis at 0. And if you do this correctly, you see that the line x is equal to 0 is the y-axis. This is the line x is equal to 0. 1, 2, 3, minus 1, minus 2, 1, 2, 3, minus 1, minus 2, minus 3. So, x is equal to 0 is also called, the line x is equal to 0 is also called the y-axis. Right. This is the first part I want you to understand. First of all, I've demonstrated how to draw lines which involves y and a certain number, a constant. Y is equal to 4, y is equal to 0, y is equal to minus 2. Then secondly, I've demonstrated the lines which involves x. X is equal to 0, x is equal to 5, x is equal to 6, etc. Now, on the last part of this lesson, just wanna do the introductory part of straight lines, because it's a topic on its own. Sometimes we are asked to find equations given the gradient and a point on a line, etc., or given 2 points, we will be asked to find the equation of the straight line. So it's a topic on its own, but on this part, I will teach you how to draw a straight line which is in the form y is equal to mx plus c. The reason why I'm teaching you this now is because when we do quadratic graphs, the next lesson, you will see that there are some questions which require us to draw straight lines which are in this form, y is equal to mx plus c. In this case, don't be confused by this expression, this equation, I mean. In this case, m is the gradient, the slope of the line. Then c is the y-intercept. Y-intercept means this is where the line crosses the y-axis. Y is equal to 2x plus 2, right? There are many ways of drawing a straight line. Okay, what you have to know is this. We can use a table, we can use the gradient and c, and also we can use the x-intercept and the y-intercept, where the line crosses the y-axis and where the line crosses the x-axis, by saying, let's say, when x is equal to 0, y is equal to, when y is equal to 0, x is equal to, right? So we can use many methods, but I want to teach you a method which uses a table of values. Like in this case, we can use the values of y which are in the range of the Cartesian plane. For instance, if we have 0 here, minus 2, minus 4, 2, 4, then if we have 2, 4, then minus 2, minus 4. We can pick any values of x which are represented on this Cartesian plane. For instance, we can say when x is equal to 0 and when x is equal to 2. So we make a substitution in terms of, we put the value of x here. When x is equal to 0, what is the value of y? So we say y is equal to 2, then put a 0 here, plus 2. 2 times 0 is 0. So when x is equal to 0, y is equal to 2. So we write 2 here. Just want to show you how to do a table of values. Okay. Then secondly, when x is equal to 2, we just do the substitution again. We say y is equal to, then we say 2, we put 2 here, plus 2. Okay, so we can say that when x is equal to 2, according to this function, which is a linear function, y is equal to 2 times 2 is 4. 4 plus 2 is 6. So when x is equal to 2, y is 6. So we can plot these points on a Cartesian plane. Let me add another 2 units. Let me add 2 units. Right, we can plot like this. When x is equal to 0, y is 2. This is the point. And secondly, when x is equal to 2 here, y is 6. Here, this is the point. So join these points using a straight line. Join this point using a straight line. Therefore, this is the line y is equal to 2x plus 2. To benefit from this lecture, you can get a copy of my start pack so that you see some of the examples which I did not do here, so that we will move together. Let's catch up on the next lesson, which is quadratic graphs.